How are you guys doing? Good afternoon. Have a good lunch? Yeah? Enjoyed the conference so far? Awesome. My name is Mark Smith. Welcome to Cross-Platform Mobile Apps with Xamarin and C#. Just kind of as an introduction, my Twitter address, I have a company in Texas where I'm from, where I do a lot of consulting and performance analysis and things like that. I work with DevWeek as a trainer and author, with Winelect as a consultant, and then I also work with Xamarin as a consultant. So I work on some of the product pieces that I'm going to show you today. But independent of all this, I think I need to tell you how I actually got into the Xamarin story. So where it really started was an app that I built for a company out in Los Angeles, which was a medical device company. So this is a biopsy tool, and it's got a touchscreen application that was built with WPF. And so with this tool, you can use your finger and slide it around, so it's a really nice touchscreen UI. Well, the problem that we ran into was that the unit itself stands about 7 feet tall. And so it's relatively large, has a big vacuum unit, a big control unit, and then of course the big touchscreen, which is one of those industrial, massive touchscreen devices. It's not like thin like an iPad. And they basically said, well, we have a problem because we want all of our sales guys to take these units out to the doctors, show the doctor, so that they'll want one of these units inside their medical service lab. And they said, you know, they can't really manhandle these things into their car. So we bought a bunch of iPads. Can you just move the app to the iPad? And I said, well, it's written in WPF. You guys realize that's a Microsoft thing, right? That's C#. And essentially my response was, you guys are nuts, right? We can't just take this app and run them on the iPad. And they said, no, we really, really need this running on iPad, and we need it in 2 months. Can you do it in 2 months? Okay, well, I've not touched Objective-C. I don't know anything really about the Mac, so I pulled out my Macintosh and got ready to start building this app. So I went to the bookstore and I bought a bunch of books on Objective-C programming. Made my head hurt, right? Have you guys seen Objective-C? Has anybody here done any Objective-C? Yeah, a couple people? Right? It's not the easiest language in the world to learn, particularly if you come from the C++ or Java-based world, because it's just completely different. There's a lot of similar concepts, but the actual programming model is quite a bit different. So this all made my head hurt, so I had to go to a better book, which made my kids a lot happier, right? They like that book a lot better. Reading them stories from programming Objective-C wasn't doing it. It helps them go to sleep, but beyond that, that wasn't very helpful. And I realized there was no way I was going to meet this 2-month deadline. And so I started researching around, trying to figure out how can I build this app and take the majority of the code that we've already written and try to bring it into an iPad device. And that's when I heard about Xamarin. Now I was feeling like this guy right here, up to that point, right? I really have stepped in it here. I've got a real problem. I'm not going to be able to meet these deadlines. And it actually reminded me of a quote from a famous philosopher. Trying is the first step towards failure, right? So I should have just said no. Right, so I found this Xamarin toolkit, and essentially what Xamarin does, has anybody here ever heard of Xamarin before? Okay, has anybody actually worked with it? Yeah, so a couple people. So the idea behind Xamarin is to be able to take the language and the framework that you're familiar with and allow you to write apps that target iOS and Android. Okay, and along the way, they also, of course, have Mono, which lets you target Linux, and they have a variety of other frameworks for things like Mono games, so you can write things for the Xbox 360 and PlayStation. But my goal, of course, was iOS, and this was ideal because it allowed me to take a lot of code that I'd already written and then port it to the iPad. So I want to show you the app itself. So go ahead and hit escape. So by the way, I didn't introduce him. This is Michael, a good friend of mine. Hello. Also is an instructor for Development Mentor, and we do a lot of Gorilla.net together where the format is somebody's typing, somebody's talking. And so he offered to type, and I said, sure, that's great. I love it. Yeah. So Michael's going to do that for us. He doesn't know this at all, by the way, so he's never worked in this. I'm going to have to lead him by the nose in a couple of places, I think. But that's okay. All right, tell me where to go. Go to Windows, actually. Windows. So I'm running a Mac here, but I do have a virtual machine, and this is the actual application. So this is running in a window. Normally it runs full screen on a touchscreen device. But you can see the app here. So you can click options and things like that. It is, again, a touchscreen. So click options. There you go. You can see it takes you through various things. You can go back. It's pretty cool. And it's all WPF with custom controls and things like that. So we did meet the deadline, or I met the deadline, rather. And so I am on the Wi-Fi. Switch back over, if you would. And let me see if I can get this to work. doesn't show up here.
I gotta restart.
Yes, the restart Reflector. So I have a little app here that's kind of cool called Reflector. And if you're on the same Wi-Fi network, it should actually show up as an AirDrop device. But it's not. So I'll just show it to you this way. So this is the same application running on an iPad. And so you can see it's going through initialization, has a bunch of animations, and eventually it will actually hit that same screen. Looks exactly like the touchscreen device running WPF. And if we look at the code, so I have both projects here. Let me just show you the one that's actually for the iPad. Yeah, no, go to Xamarin here and just click on that Encore Center. And so this is the actual code for this. You can see it's got a bunch of views. These are all actual iOS views, but if you scroll up a little bit, there is a directory there for models. Open that up. And you can see all of this code right here is actually the same code that we were running in the WPF app. Okay? Now, I didn't do a very good job here of actually doing code sharing because that really wasn't my goal. My goal at the time was to try to meet this deadline so that I didn't get fired. And so the reality is the code sharing that I got out of this is probably close to about 50%, which is a little low for a lot of projects if you structure them right. And that's what I'm going to talk about today, is how we can actually structure our applications to be able to do a significant amount of code sharing between the platforms, right? Because that's our goal, is to write the app essentially once, all right? So that I don't have to have 3 different development teams, you know, one guy in Java, one guy in Objective-C, and then one guy in C# for Windows Phone, where I can just have one, and then I'm going to be sharing a significant portion of that code. Okay, so go ahead and switch back to the slides from my There you go. All right. So what is Xamarin? There's a couple of different ways I'm going to describe this. First, Xamarin is essentially a series of tools, but ultimately lets you use C# to be able to build your apps. Okay? How many of you are C# developers? I'm going to guess almost everybody. Right? C# is a great language, and what Xamarin brings to the table is it lets me use LINQ, it lets me use things like async await, generics, all that on the mobile platform. Right? And by the way, it even lets me use things like link to XML, HTTP client, right? Stuff where if I had to do that natively in that platform, it's kind of messy, particularly XML on an iOS platform. It's kind of mind-bending the way that stuff works. Right? This lets me use link to XML, so it's really nice because I can use some of the things that I already know. In addition, I can of course target my 3 primary platforms. Xamarin supports iOS and Android, all variations thereof, and then of course we also have Windows Phone. Right? So if I'm going to support the first 2, I might as well support Windows Phone as well. Even though it's a relatively small market share, I might as well work across all platforms. And in that case, I might even throw in, say, Windows 8. Right? So go ahead and port it to the Metro platform as well. But you can also build games. Right? So we have a toolkit called Mono Game, and there's another one called, I think it's Coco 2DS, something like that, that will let you actually write games with this model. So as an example, I showed this to Michael a couple of days ago. When my daughter turned 13, like 2 or 3 weeks ago, she is heavily addicted to Flappy Bird. Right? You guys have probably seen Flappy Bird, right? So I wrote her Flappy Birthday app. It has her little head, and as you tap it, it moves up and down, and it has essentially the same side-scrolling UI as Flappy Bird. And it took me, I think it was probably close to about 700 lines of code. Right? So it wasn't significant. And I could run it on Android, iOS, and in theory I could have ported it to an Xbox 360 or a PlayStation if I really wanted to. Right? So it's fairly portable code from that perspective. I can also run it on Google Glass. Right? So if you want to actually buy yourself those really nice glasses with the little camera, you can write apps for that. Or you can even do some of the new Android wearable tech. This is actually kind of interesting because Android announced this, like, I want to say it was, what, maybe a month ago, right, when they had the new SDK that came out for their wearables, the watch stuff. And that day, Xamarin released an SDK for it. So the day Android announced it, they had an SDK for it. And I can tell you just from the inside, they don't get any advance notice to do this stuff, right? They're not on some internal list from Google or from Apple, right? They're actually writing this stuff as that it's released to anybody. So it's any of the public stuff that you're getting. So you can actually write apps for all of these different platforms, which is pretty cool. We have 2 different IDEs we can use. You saw one here, it's Xamarin Studio, but you can also use Visual Studio. Right? So they do support Visual Studio running in Windows. I'll give you some caveats to that, just kind of as we go through it. And then what I want to show you is kind of more of a deep dive in terms of how it works. Right? So just to give you some insight into how the platform is actually structured and what's actually happening under the covers. So first, one key advantage that we have to using Xamarin is that it actually creates native applications. Right? So it's not a porting layer where it's going to create some sort of abstraction that is then kind of at runtime creating its own UI, like Flash, for example. That was one of the common criticisms to something like Flash because the app didn't look native because it wasn't really native. This actually generates native applications. And so when it runs on the iPhone, it is an iPhone application. Now, there's a lot of advantages to this. One of the key points here is that because it is a native app, we can actually take advantage of all of the platform capabilities. You want to use the camera? Great. You want to use the maps? No problem. Right? So any of the features that are specific to that platform, you can totally use from C#. And it looks like a C# API to you, but it's really just invoking the native platform services that are there. So there's nothing that you cannot do in C# with Xamarin that you could have done with a native Objective-C app, for example, or a Java app on the Android platform. Now, depending on which platform we're targeting, iOS versus Android, there are going to be some differences in terms of the actual execution, and it's predominantly because of the way the platform itself is structured. So, one interesting thing that comes out of this, by the way, is this was a quote. I just inserted this slide today because I saw this on Twitter. So Steve Hall works for Xamarin, and last week they had their internal conference. They call it a Summit. It's stupid, I know. But they had just had a session on Xamarin competitors at Summit. It was a short session, right? So it is kind of interesting. There's not a lot of competitors in terms of the space itself of what they provide. In terms of the breadth of features that are there, I thought that was kind of interesting.
Almost all the other ones are HTML things, right?
Yeah, you can of course do HTML, which is a cross-platform capability as well. The problem is you can't get to all the platform services. So if I'm running on iOS, here's the basic model of how it works. First, they don't do JIT compiles in this world because Apple's hardware prohibits that. You can't take a data page and turn it into an executable page, so you have to pre-compile everything up front. And so they do what they call ahead-of-time compilation. So they take your C# code, they compile it to IL, just like .NET does. Then they have a post-compile process that takes that IL and generates native ARM code specific for either ARM6, ARM7, or ARM7, I think it's ARM7S. Is that the designation for the other chip? So they generate native code for it that you then would deploy to the platform itself. They do have a runtime that's built into it, so it's based upon Mono. Right? So the same Mono engine and garbage collection and all that kind of stuff that you probably are familiar with in .NET is also here. And so you don't have to do any sort of release or any sort of memory management from that perspective. It'll take care of it for you. They also have a version of the base class library as well. So a lot of the common things that you're familiar with, such as system collections generic and lambdas and link and system tasks, threading tasks, that kind of stuff is all present in the framework. Then you have underneath that the actual core frameworks themselves. So these are things that are coming from Apple. So that's things like MapKit, CocoaTouch, UIKit, stuff like that, that you're interacting with in order to actually create your native UI. Okay? And so your code sits here, and then it's utilizing all those frameworks. And then, of course, we have iOS underneath that across the bottom. But the key point is you have access to all those services. So when iOS 7 shipped, for example, you could actually access iBeacons that day. So the day that the SDK was released and you had public access to it, you could actually use those services from within your C# app. Right? And that's a key feature from the platform itself. The Android side looks a little bit different. Because in an Android app, they actually have their own VM. It's called DevWeek. And so this one's a little bit more complex because you actually have two different virtual machines that are kind of owning the same process memory. Right? So when we allocate an object over here, there's actually a managed representation that's on the Mono side, so there actually is a virtual machine here. They do JIT compilation here. All right? So they just take the IL, just like you would in the desktop world, and they actually have a JIT compiler that's running in this VM, and they're creating native code on the platform as it runs. Right? So the same way DevWeek does. But when they allocate memory, we're allocating some of it over here, and it may be that we're allocating some of it over here in DevWeek as well. So if it's a native Android thing, for instance, maybe it's a widget like a button, for example, that's going to have a wrapper on the Mono side to represent that button in the managed world so that C# can talk to it. But it's pointing at an actual object that lives over here. And they take care of all the details for you. So when we clean it up over here, it gets cleaned up over there. Right? So there's nothing that you actually need to really do in response to this, but there is more complexity just because of the platform service itself. And much like iOS, we have the Android iOS platform, or Android operating system platform here that we're talking to so that we can access native things in there so that I can deal with mapping, or I can create UI, text views, and things like that to be able to present onto the screen. And then of course we have the Linux core that's underneath this. Okay, so these are our two application runtime models that we're actually working with. Now, when it comes to code sharing, what we've seen is there's a fairly similar kind of app structure that we're going to use. One key point that I want to make clear in terms of Xamarin is this is not a write once, run anywhere type solution. Right? The idea is you're going to write an application for iOS and an application for Android, and your UI is going to be specific to that platform. Right? And there's advantages and disadvantages to that. From an advantages perspective, it looks like that platform. Right? Users are not going to be surprised by its behavior or by the way it looks or anything like that. It can use all the native sort of UI platform services that users know. And so in terms of behavior and kind of activity of the application itself, it's going to work the way users expect it to. But it does mean that we're going to have some piece of our code that's going to be unique to that platform, right, to represent that UI. We then have a section of potentially shareable code. And I say potentially because it depends on how you structure it and how much you really care about sharing. Right? So in my case, when I built the iOS app, it really wasn't the goal of mine to ever port it to Android, and so I wasn't really concerned with that aspect of the code structure. But in theory, you can get typically about 75 to 80% code sharing in most applications. And so that's going to be predominantly your business logic. Right? So if you're familiar with, say, Windows 8 programming where we use things like model, view, model design patterns, your view models would be the shareable components that you potentially could move across different platforms. We then, of course, have platform bindings themselves. So this is our access to the native APIs themselves, kind of like pinvoke sort of wrappers that you get in Win32 or things like that. This, again, is platform specific, but that's provided by Xamarin. So you're not writing any of that code. That's just what you're consuming, but it is, of course, platform specific in this. So the thing that we're going to be concerned about is this area here. Right? So the application code that we write that's driving the logic of the UI, right? So the commanding, if you want to think of it that way. Potentially the validations that you perform. So as users input data, what are we doing to validate that? Data storage, so when I want to store it in a database or when I want to push it up to the cloud or access a web service. Those are all things that I potentially could share. Right? So depending on how I structure it, I could potentially share those aspects of the code. And then there's also the section here for components. So I'll show you that when we talk about it here in a second. But the idea is Xamarin does actually have a component store. Got a bunch of free components, like for instance, if you want to talk to Azure Mobile Services, Microsoft has a component for that. You can then include that component in your app, and it's a cross-platform component. You have the same code on all three platforms to be able to read and write data to Azure Mobile Services. So that's kind of cool. So here's just an example of some code sharing from a very popular application. If you go find his blog, it's iCircuit. So if you go search for iCircuit, this is on Windows Phone, iOS, Android, and Windows RT. So he's got it across all these different platforms. Oh, and he has it on Mac OS as well. And every time he makes a change to the application, he publishes on his blog his code sharing statistics. So he uses Mono for Mono Mac for Mac OS, Mono Touch and Mono Android, and of course Windows RT and Windows Phone 7. And so this is his stats here. The green is his shareable code. Okay, so on the Android platform, 86% of the code comes from the shared code base. And then he has to write 14% to be specific to the Android side. Right, so now he's trying very hard to share that code because he's supporting multiple platforms. Right? What's the advantage to that? Well, it means that when he fixes a bug in one platform, it fixes it in the other platforms too, in theory, right? Unless it was something weird about how that platform was interacting with the data. But it means that I don't have to chase the same bugs across all the different platforms and different code bases, right, with different developers and things like that. So this is interesting because you can go look at his blog, it's iCircuit, and see some of the stats that he actually produces there. Okay, so Michael, do this for me. Go ahead and switch to Xamarin Studio on the Mac, and let's just build a couple of quick applications. So go ahead and do a file new solution. Perfect. And create me, go to iOS and let's use iPhone. So notice it looks very much, this is Xamarin Studio, and it looks very much like Visual Studio. All right? So Xamarin Studio is actually a derivative of another product that was open source, still is, called MonoDevelop. And so MonoDevelop was an IDE that was influenced by Visual Studio. This is Xamarin's branded version of that, but it is still an open source tool. 90% of this code is part of the open source branch. And then they add their own add-ins and things like that to support their infrastructure for things like validation and licensing and stuff. So let's start with an iPhone app and pick the single view application.
Single view.
Yeah, right. It's right in the middle.
Thank you.
There you go. And go ahead and put it on the desktop for me just so that we have a known place where it's going to be. Yeah, there you go. Okay, and make the name of it, call it phoneword.ios. That's the solution is just phoneword. And then make the project name phoneword.ios just to distinguish it, because we'll do an Android version as well. And change your solution to AMP.
I did that in the wrong one.
Yeah, you did it in the wrong one. That's okay. Say okay. So that should look fairly familiar because it's very much like the solution, add new project in Visual Studio as well. Now this is also going to look relatively familiar. Notice we have a Solution Explorer over here. They call it a Solution Pad, but it's essentially the same thing. And the structure is identical. In fact, the actual project format is the same as Visual Studio. So I can actually open this project in Visual Studio as well. We're using the same MS Build tooling under the covers to be able to build the app itself. So you can see I have a nice editor over here. What are you doing?
I want to change the fonts.
I think you can just do
plus.
Yeah, actually, I don't know that that works. Go up to, if you want to do that, go to Edit, I think. Oh, actually, this will do it.
Okay.
Fonts.
Oh, yeah. Why didn't I just make fonts?
There you go.
All right. Let's make those.
Yeah, make it
18 maybe?
Sure. That way everybody can see it. There you go.
Better, guys?
That good? Okay, and so this is an iOS project. And so there are going to be things that aren't going to look quite familiar to you. For instance, if we look at our Solution Explorer over here, you can see we have a bunch of files here, and they have main, like start at main.cs, Michael. So if you notice here, we have a main.cs, which is our main entry point, much like any .NET desktop app that you've ever worked with. It's a static void main, and it calls a static method called UI-application.main that just simply launches the whole system. This is actually coming from UIKit, so that's part of the iOS framework itself. And then it launches a app, what they call an app delegate. So a delegate in iOS, I don't want to get too far into the different pieces of this, but a delegate in iOS is essentially a class that implements a set of callbacks that the operating system interacts with. Okay? So it's not a delegate in the sense of .NET, it's more like a class that's going to manage callbacks from the application itself. So this is actually going to go ahead and go to the appdelegate.cs, if you open that up, Michael. And so you can see this derives from a UI application delegate. This again is a UIKit class. That's a native Objective-C class, okay? We're deriving from it, and we have, as part of that, a bunch of overrides that we can hook into that iOS will notify us about things that are happening in the system. So as the user interacts with our app and switches away or switches back, we'll get notifications about that through these overrides, okay? And this is just straight iOS stuff. So if I were doing Objective-C, I would have the same style of work to do here, okay? They call them something else, but the management of it is going to be the same. The messages that are being sent to this. Are you bumping it up a little?
One more.
Okay.
It would just be an Objective-C, so it would hurt your eyes.
Yeah, it would hurt your eyes. You'd have to, probably wear glasses for the rest of your life, but that's okay. So our UI that we're going to build here is actually part of this thing called a storyboard. And so if you would open that up. So here's a cool little trick. So notice that it opens up right here inside of Xamarin Studio. So this is relatively new for the platform. Prior to current releases of Xamarin Studio, the IDE, you actually had to use Apple's Xcode editor. So they have a designer in there called Interface Builder. You would open up Interface Builder, and then you would actually design your UI. They've now put that designer right here into Xamarin Studio so that you don't have to switch out of the tool to be able to do your UI. But you can see we get a toolbox over here with a bunch of stuff in it. So Michael, if you would, scroll into the toolbox here.
Okay.
And find me scroll down a little bit.
Can I type?
UI label, Zach, just type label.
Got that one.
Yeah, there you go.
Okay.
And drag a label up here to the top. Can't just stick it at the top of the
Top
screen
right here? So
yeah, that's fine.
Okay.
Not quite that high, but
Right,
yeah, there you go. And then come over here to our properties. So this should look fairly familiar, right? We have a little property box down here. And don't give it a name yet, but change the text from label. So there you go. Change the text from label to say enter a number. So here's our goal. I want you to be able to type a number into this app, except I want you to be able to use alphanumerics. All right, so to be able to pick some string, like, a lot of companies will come up with a catchy phone number to say, instead of giving you a string of numbers, which you'll never remember, they'll give you some catchy word that happens to match that phone number. At least they do that in the US. And so next I want a text field. put it right below that. That's fine. Yeah, not in the center, but that's fine. There you go. You can stretch it out a little bit. Perfect. And let's go ahead and fill this in with some text already. So change that text to be 1-800-Ferrari. Because that's what we want, right? And then go ahead and throw a button underneath that.
All right. Wait.
Oh, the beach ball, Jeff.
I've done nothing.
What did you do, Michael?
I clicked on it. I'm sorry. Really?
You have to force quit it.
Yeah.
I don't know what you did. But yeah, if it doesn't come back in a second, then yeah, just drop out of full screen. Right click on it. Yeah, there you go. Oh, no, it's yeah. So click it again. Sorry about that. I don't know what he did. I'm going to blame it on him now.
Sorry. I'll do that again.
You should be able to. Is it already there?
Go
Yeah,
there.
it's right there. So just
Go
open
back
it
to
up.
storyboard. See what we got.
And,
I may have to put the label back.
Yeah.
I do. All right. You guys ready for a review? Okay.
So what does he need to do first? Right. Yeah. So just throw. Yeah. Instead of using the search box, just.
Yeah. Just let's not click on that anymore. That didn't work out so well. Okay.
So yeah, just enter a number. Perfect. And then.
Gotta get rid of that though.
Yeah, and scroll down. So everything you want's right here. So there you go. You want a text field. Yeah.
Yeah. No, I really wanted it there.
By the way, this is an alpha build. Okay. So this is not the released build. You can get to this. This is free. You can download it. And if you go, he's going to keep adding to it. If you go up to Xamarin Studio, there's a check for updates that's there, and you can change what they call the release channel that you're on. So there's a stable channel, a beta channel, and then if you're really brave, an alpha channel, which is what we're happy to be on here, because that's where the designer lives today. So for the designer bits, it is Mac only today. Okay, they are going to release at some point a Visual Studio version of this. All right, but let me tell you some of the restrictions that are here, at least on the iOS side. So Apple has some very definitive requirements in terms of building iOS apps, and one of those is you have to have a Mac. And so you do have to have a Mac to do this, but you can run it from Windows, and presumably at some point we'll have a designer in Visual Studio, but you'll have to have a Mac machine with Xcode and the SDK, and they have what they call a network build host. And then what happens is you pair to that network build host, and it just does it all over the network to build the app and package it and get it ready for deployment. So Apple requires you to use a Mac to actually build the tooling. That's the only place the SDK is available, and to violate that would get them in serious legal trouble if they don't. So you do have to have a Mac, but you don't have to use the Mac, is what it comes down to. So you put your button, yeah, go ahead and change the text for that to be translate.
Mark,
Yeah, go ahead.
is there any alternative to having owning a Mac?
Is there any?
Alternative to?
Okay, so from a legality perspective, legally, you have to have a Mac, all right? But really, what the requirement is you have to be running Mac OS, all right? So if you can find a way to do that without a Mac, then you could get around the Mac side. But you know, from a legal perspective, Apple's gonna require a Mac. So I can't say anything more than that without getting myself. Yeah. So if somebody else would like to say anything, that's fine.
So if you were developing in Visual Studio,
Yes.
and you wanted to do, where would you do the front end development actually on the Mac?
No. So what happens is, in Visual, and we'll do this because we'll call it Visual Studio as well. When you do the build, the Visual Studio plugin that's actually doing all the iOS stuff is talking to a network build host. It's this little blue icon down here. And so they're essentially network remoting over to that build host to get the SDK and actually do the final building of the package itself. Because they have to use Apple's libraries. I mean, that's where the Objective-C bindings all live. So all that stuff has to happen there. So they're just pushing it all over to the Mac to do the build, create the package, and then pulling it back, and then you can deploy it. But it's all done, you know, the actual creation of the final package has to be done in Mac.
Is that so? Can you do that as like a cloud thing? So if you don't have any Macs in your corporate network, can you go to?
There are some cloud providers. So I forget the names. I think one of them is like macincloud.com. So there are companies out there that do virtualize Mac OS, presumably on Mac hardware, but that you can use to do that. And you can also just buy a series of Macs as long as only one Mac is being used by one developer at that moment in time. So you can't share one Mac from two different build hosts. It's a one-to-one connection. That is also a legal requirement for Apple. But you know, in theory, if you had say 20 developers, but only 5 were doing any active work at any given point in time, you'd have 5 Macs, and then you use those filters off the network. So you can do that. Yeah, put one more button in there.
Is it Visual Studio plugin? Is it you have to pay for that or is it free?
Is which free?
Plugin for Visual Studio.
Okay, so Xamarin has multiple licenses. To get the Xamarin Studio plugin, you have to be at the business level, and we can pull it up. I don't know what the pricing is. I want to say it's like, well, I don't know. I think it's like $900 for the business level. And there's 2 other levels below that. So there's a free version. The free version doesn't include the Visual Studio plugin. So that would be, you would be using Xamarin Studio, which is what we're using here, which you can use. But if you want to use Visual Studio, you have to be on the higher level license tier. So that's kind of how they make their money is, for guys that want to use Visual Studio, they charge you more because that's extra added stuff. So.
And the way the free one works is you can build small apps, but if they get above a certain size.
Yeah, it's 64K, and it's actually just your code. So anything that's part of the base class library that you use, they don't count that against you, but the free version has a limit on the size of the app that you can build. And then you need to move up to the indie version or something like that, which is a paid product.
So can you install Xamarin Studio in PC?
Yes. So Xamarin Studio runs cross-platform. It is both a Mac and a Windows application. On the Windows side, however, it does not support Mac development, iOS development. Okay, so it's only Android when you're running it on Windows, which means you have to run on Mac to be able to do the iOS side, which you have to have a Mac anyway, so I don't know that that's a big restriction. I think, and I don't speak for Xamarin, by the way, so I'm just a consultant, right? Which means they don't tell me anything and they just tell me what to do. But ultimately, I think where they're kind of focusing, if I kind of read between the lines of what I see in the company itself, is I would say that they are more interested on the Windows side of focusing on Visual Studio, of adding things to Visual Studio because they expect that if you're a Microsoft dev, that's where you live. You don't want to move to a different tool, right? So their big advancements really are on the Mac side of Xamarin Studio and Visual Studio on Windows side. So they're not doing a whole lot on the Windows side.
Are we not then developing general, I mean, like in libgdx where you have a desktop app, and it's the
Yes.
first thing you do. Are we not doing that? Are we having to focus first on each of the operating systems?
So I'm not sure I completely understand the question, so let me see if I can repeat it back to you.
Do we have to do the UI either for iOS or Android in the first place? Don't we have a way of doing some generic work? Like
Yes, you could do generic work. We'll do that in a moment, okay? But we're going to start here with UI side. on
for the
iOS.
UI?
Yes.
There's no way of doing
That, so there's not any combined technology today that lets you build the UI in one cohesive package and then deploy it across platform. So, but hold that thought. Okay, so wait a couple months. I can't say any more than that, but wait a couple months. So, okay, so you have a call button. Perfect. All right, so let's do this. So this is our UI. Let's save that.
Save.
Thank you. Now, where we actually put our programming logic here in iOS is we always put it in what they call view controller. So iOS uses model view controller, right? So that's the MVC pattern. You guys are probably familiar. I know Dino is, right? So the MVC pattern, we have models, that's our data. We have views, that's our storyboard. And then we have controllers. That is, in the iOS world, a view controller. So Michael, if you would, open up the phoneword.i, I think you've got a phoneword.ios.
This is the
Yeah, open that up.
that, yeah.
So notice it's a CS file. Double click on it. And just hit use original file. I don't think we changed anything. Yeah, that's fine. So notice this derives from UI view controller. That again is a native UIKit class. Let's go ahead and rename this though. So just click on this and do a command R. There you go. All right, and name it just phone word view controller. So just get rid of the underscore iOS. And go ahead and check the box that says rename the file. There you go. And click OK. There you go. All right. So this is our view controller. This is where we're going to put our logic. And really what we want to do here is you can see there's a bunch of overrides. Right? That's kind of the way things run is iOS sends us messages. Those are intercepted by the framework and they turn into overridden methods that we can then put our code in here. The one that we really care about here is this view did load. This is a notification that tells us the view is ready to be presented. So whatever's in the storyboard has now been turned into UI things. And so this is where we're going to put our actual programming logic for that. Now, we need to do one more thing, Michael. So go back to that storyboard real quick. You still have it open there.
Yeah.
And so go ahead and click on the 1-800-Ferrari, just to select it. So over here in my property box, if you scroll to the very top, there's a field here for name. So if I were doing this in Xcode, this would be a painful, kind of tedious thing where I'd have to hold the control key and drag down to the header file that they generate in order to create what they call an outlet. That's the term from iOS. In the Xamarin world, for this designer, I can just give this a name. So actually call it phone word text. Yeah, phone word text, perfect. Click on the translate button. And click on one and then the other. There you go. Yeah, click on that. There you go. And name this one translate button. Perfect.
Okay.
And then click on the call button and name that a call button. Perfect. Okay. Yep, that's fine. Tab out. And go ahead and save that too. You can, yeah, perfect. All right. And then switch back to the view controller. Now, in this code here, if he types in, say, this dot phone word, you have phone word. Switch back to the storyboard.
Did I not save it?
We'll click on the text field again. Yep, and then on the name there, just go to the end of it and get rid of the last T and put it back and tab out. Like I said, it's an alpha. Okay. Now, notice that this thing here, if he opens up this disclosure triangle,
Which just was
the little open file up, so
Oh, yeah.
it's got a little, just like Visual Studio, if he opens that up, it's got a designer file that's behind it. See, it's not putting in there. So go back to the storyboard and save it. And it seems like it's saved, so click it.
See a little,
It's got a name.
little bit of action to do a save.
There you go. It's still not putting it in here, so it should be putting them right in here.
Yeah.
What did you do, Michael?
I don't actually.
Oh, wait. What's happened there? You've got a phone word controller 2. Ooh, what happened? So switch back over here. Why is it called 2? Double click on that?
You know what? I bet because when it crashed or something.
Oh, yeah, and it's got.
Reveal open.
No, hold on. Close that.
See this one and this
Oh, it's got 2 of them. So open up the.
I bet this one has it,
Yeah,
right?
it probably does. And no, that's your other.
okay,
That's your other. It's not the design file, but it's got the wrong names in here too. So no, don't.
Yeah.
Don't.
You don't think that's it?
Yeah.
Okay.
It's the designer file that we're looking at. But see, it's got the wrong registered name. But go back to the storyboard. Let's do this. So go here, and so notice this class field here. Pull that down. So click actually on the document outline of your view controller. So a little bit of diagnostic here. So click on the view controller.
Oh yeah.
Yep. And then, so pull this down, this class, and that's not the right class, so you renamed it.
Yeah.
So get rid of that.
Try to.
There you go. Save that.
Okay.
Let's see what we get now. So now you have
that one.
and that one, except that one's
One of
not right.
these.
You have 2 of them now?
Yeah, not two.
Nice, that's sweet. So you have a 2 and a 1. They look the same to me. So switch back over to the storyboard. Let's just create a new one.
Should I delete one of these?
Yeah, well, delete both of them actually.
Okay.
Just delete both of them. Right? Click and delete.
All that?
Yeah, delete it. Yep, remove, delete. Delete. There you go. That's fine. Click OK. So right click on that one. The actual whole thing. Right click on that. Delete. So remove that one too. Yep. There you go. Okay, now click back on your view controller. Let's try that again.
Here.
Document outline, yep. And change the class name. Let's just call it phone word.
Called phone view controller.
There you go. Okay, now we have it. That's good. Okay. There we go. Okay. So notice what we have here is they use attributes all over the place to be able to kind of manage some of this. And so you can see that I have actual elements here that match up to the UI that we've actually created here. So a UI button can match up to those buttons, and a UI text field that matches up to the text field. So now if we go to our actual phone view controller that's there, yep, and go ahead and override for me view did load. That's really the only one we care about. Did load, perfect. Yep, go ahead and call base, that's fine. Now what we can do here is we can then start wiring things up, and we're just going to use regular .NET events to do that. So let's take our button actually. Let's use the translate button. So translate button. Yep, that's it. Dot. And instead of a click event, in iOS they use touch up inside. All right, so that's the message that gets sent to you. And so we're going to go ahead and wire up to the touch up inside. Touch up, there it is, inside event. So this is actually mirrored into an event on the .NET side, or at least on the mono side here. And then what we're going to do is just go ahead and use, yeah, it doesn't matter, just lambda. There's fine.
Okay.
All right, and then arrow goes to,
This I don't like this very much.
well, that's,
I want this program.
Well, you picked the wrong one. So go ahead and put your curly braces.
Okay.
So notice it's just a lambda expression here. I can use the kind of stuff that I'm familiar with that all of our code is actually set up to. So what do we want to do here? Well, when we actually click that button, I'd like to take the number that's currently in the text field, and I want to translate that into a numeric number. So go ahead and say string number equal phone word. What you call it? Phone word number.
Phone word text.
There it is. Dot text. Perfect. That will give me the value that's in there. Now I'd like to go ahead and use some code that I've already written to do this. So right-click on our project and say add files, or add existing, just say add files. Add files. Add files. Scroll up, add files. There you go. And back up to the desktop. And I have this phone word translator.cs. And so this is a file that I've already written.
Say open it.
Just say open. Copy it. There you go. If you go ahead and open that file up just to show us what's in there, Michael. So you can see here that it's basically just a static class that has a static public method here, takes a string, and then walks through it and says, okay, find all the numerics, return those, otherwise go ahead and translate it from whatever the character is, A, B, C, D, E, F, that kind of thing. So we're going to use that class. So just say string translated number equal phone word translator dot, and it's going to be core dot, so we don't have the namespace up there. Just say core dot. There you go, phone word translator dot to number, pass in your translated number. There you go.
Right.
And then we can take that number and let's go ahead and actually populate our call button. So we can basically use that as the text for our call button. So put me an if condition here, just say if string.is null or white space. And pass in translated number. So if it comes back as null, meaning that we couldn't translate the number for some reason, then go ahead and do a curly brace. And let's take our call button and say call button dot text. I'm sorry, this is iOS. Back up. Set title. Okay, so here's the thing. We are talking to a native iOS element, and so you've got to have some understanding of what the UIKit framework is, because you're using these native elements here. And so in UIKit, we use this set title message. Go ahead and say just call as your text. It takes a second parameter, so comma, and it's UI control state dot normal. So I think this is the hardest part, is kind of knowing the native UI side, because you're building a native app here. So control state normal, and then go ahead and say enabled equal false. So if we don't have a valid number to do this with, we'll go ahead and disable the button. Else, so put an else condition on there. Else, there you go, and copy that, the call button set title, and the enable. Yep, so both of those. And put them into our else. And set our title for this, and make that true, and say, leave it as called, put a space.
A space?
Put a space after call.
Oh, got it.
So call space, yeah. There you go, and then add the translated number. There you go, perfect.
Okay.
And then make your enabled state true.
Okay.
Okay?
We ready?
And then we could add in code here to actually hook into the call button as well. There's a method that you can use to open a URL that will then do the call. So we can do all that. But let's go ahead and build this. And pull up here on the toolbar up at the top. So pull that down right there.
That,
Yeah, so notice this drop down here. This is allowing me to actually say what my deployment target is. Okay, so right now I have an iPhone actually plugged into this, and by default it kind of said, oh, you obviously want to deploy right to the device, which is actually a good thing. You probably do want to test on a real device. But let's use the simulator here. So just pick one of the iPhone Retina. Yeah, either one, 3.5 or 4 inch, doesn't matter. And go ahead and hit the play button. And let's see what it does. So it should pull it up in the simulator.
Simulator's coming. I saw it.
Yeah, I see it in
It
there. There it
is.
goes. Scroll. Go ahead and go to window. So
Oh,
it's too
you know
big.
what? I didn't
No, it's
know
fine.
I
It's fine.
did
It's
that.
fine. Go to window,
Yeah.
scale, and make it 75% or 50%. There you go. So there's the whole UI. Okay. Now he's got his number up here. Hit translate, and notice then it translates to whatever the phone number is. Okay. And at this point, he could click that, and if we had the code there, it would then dial the number. All right. But the point is that we're just using C#. Right. So all the stuff that we've done here is pretty easy stuff that you guys have done all along. Right. Now we obviously have some. Go ahead and move that out of the way and switch back over here. We obviously have some stuff that we need to learn here. So we have slightly different semantics here. It's touch up and style instead of click. All right, and you'll see here in a second that Android's going to be the same way. We're going to use Android semantics whenever we're building Android UI. But this code here is actually going to be the same. Right? So the actual processing logic of what we do when you click that button is going to be identical no matter which platform we're on. So Michael, go ahead and right-click on your solution up there. Let's see if we can do this in better time, because that was really slow.
Add a new project?
Yeah.
Okay.
And go to Android, so C#, yeah, that's fine, Android application, and name it Android, or phone word Android. So this one's actually, the designer's a little more stable. It's been around a lot longer, so click OK. Okay.
There basically wasn't one, right?
Right, yeah, no, there wasn't one. So right-click on that, make it the startup project for me. Thank you. Now, in this case, notice my project structure is different. I have a folder here for assets, I have properties, and I have resources. This is an Android convention. So in Android, we have an assets folder for things that are not bitmaps, and it's for other stuff like data files, XML files, and stuff like that. We have resources folder here that is actually our bitmaps, all of our XML layouts, and then string values and booleans and stuff like that. And then we have down here this main activity.cs. You won't find a main entry point here because Android doesn't use a main entry point. Instead, we activate activities. And so this is actually this is going to be our main starting point here because of this main launcher of the tree. So this will be by default the place where Android actually begins execution. So let's go ahead and add our same UI in here, Michael. Go ahead and open up resources layout, main.axml. So normally it's just XML in the Android world for those of you. Has anybody here done a native Android? Okay. So it's normally just XML, but in this case they use AXML just so that the designer itself knows to activate when we hit that file, so we don't have to right click and say open with some other designer. So go ahead and delete that button at the top here. Yeah, and that's fine. Name the text there, so just say enter a number, just like you did before. Yep. And then drag me a edit. So go ahead and scroll down a little bit. Yep, keep going, keep going. Right there, stop, scroll up. So there's a plain text here, drag that on there. All right, so this is just a linear layout. For those of you that aren't familiar with that, it's kind of like a stack panel, right? Stacks things left to right or top to bottom. And then go ahead and throw, yeah, so 1-800 Ferrari. See, he's already got this. He's never even seen this design.
I literally have never seen Android.
He really has not seen this before. This was a risk for him. All right, and so go ahead and throw me a couple buttons at the very top. There you go. Drag it and drag it. Okay, so that button, name it call. Translate. Yeah, thank you. And then second button, name it call. Okay, now I'm gonna have to lead him through this part. So now in this case, we don't have a name here, okay? Because Android does things a little bit differently when it names its elements. Instead, if you click on, go ahead and click on your 1-800 Ferrari up there. Let's start with that. So up here at the very top, we have this ID, and it has this weird syntax of @ ID / and then some name. That's Android's convention for being able to identify some element that's inside of our layout file. And so, again, this is an Android thing. When Android runs this app, it's going to use this layout file, and it's going to use its own native services to render it. And so all these properties are coming right off of the Android UI. And so go ahead and name that, yeah, phone word text. Right? That's great. Okay. Click on our button and name that translate button, just like you did before. And then click on call and make that call button. Perfect. Now what that's actually doing is if he opens up this resource designer.cs that's inside of our, yep, right there, that's actually adding to this auto-generated file. So this is, again, for those of you that are Android developers, this is your r.file, okay? And so it's basically putting constants in here. If you scroll down just a little bit, Michael, we'll find, keep going, IDs. Okay, so it hasn't built it yet. Go ahead and build it. Just do a Command B. Yep, there you go. And we should see this file suddenly regenerate. Yeah, and that's fine because that doesn't exist anymore. So go ahead and delete actually that code right there. Just delete it. We can just get rid of it all together.
How about all of it?
Yep, get rid of all of it. Now, and switch back over to your resource designer. And so now notice we have a couple strings. Yeah, go ahead and close that. Okay. So you have a count there you can get rid of as well. So we don't need that field. So now we're going to do exactly the same code that we did before, right? So here, right after we've done the set content view, this is actually just loading that layout and setting it up as the content for this particular element. We should be able to say, translate. Did you call it translate button? Build it again, Michael. And make sure you saved it. That's important. So go back to the main XML up there. Let's save it. Is it saved?
Give it a little nudge.
Yeah. Oh, okay.
Save. Okay.
So build it again. Just to make sure it builds. That's part of the compile tooling that's going to generate those IDs for us. Normally it picks that up. I'm not sure why it didn't. So go to main activity. There you go. It's right next to it. It's right next to it. Main activity. Right there.
Oh, okay.
And lots of tabs open.
Okay.
Yeah. So there you go. Say this dot. And where's the translate? Should be there.
Did I somehow name it wrong over here?
No, you did right. Let me see. Let me make sure. Click on translate at plus ID / translate button. No, that's right. So click on the ID field and just go to the end and get rid of the end and put it back in tab out. Let's see if that does it for us. I don't know why it's giving a struggle phone call. It's weird. So main activity. Try that again. No? Huh.
Beta. I mean,
No, actually this one's, well, it is the alpha build, but that shouldn't matter. So, open up the resource designer.cs. Let's just see, scroll down.
Oh,
There it is, yeah, they're all there. Okay.
I gotta do ID
Yeah,
dots.
so that's fine. All right, so go ahead and close this. So that it generated them. It's
Okay,
good,
cool.
it's good. So go back to your main activity. Okay, so he was trying to actually look for a field, but it's not going to be there because here's what we have to do. So go ahead and create me a edit text. Yep, space. And call this phone word, whatever you want to call it, phone word number. Yeah, phone text, that's fine.
Okay.
Equals, and we're going to call an API here called find view by ID. All right. So find view by ID, find view by ID, and it's a generic. Okay. So it's a generic. You need to go to angle brackets. That's an edit text. There you go. He's never seen Android before. Right. And what we want is resource dot ID dot, and there's your elements.
Cool.
So he wants phone text. Do the same thing. Just copy that and make it 2 buttons for our call button and translate button. Okay. So this is the Android way of identifying these, and so we're just caching off the wrapper object that's going to represent that UI on the Android side. So we have a translate button, and it's going to be a button. And so our resource ID is translate button, and one more, which is actually we don't really need to call that since we're not going to do anything with it. That's fine. Yep, and so let's go ahead and wire up our same event. So how do you think we're going to do that? All right, how did we do it before in iOS?
With the plus equals.
Yeah, just an event, right? Same thing here. So we can say, you went ahead and added it in.
Well, don't we need to set the text on?
Oh, that's right. Yeah, that's right. So translate button dot, and this time it actually uses a click event. All right. So in the Java side, it's actually a set click, but we're going to say click plus equal. And again, we can pick any one of our styles here. It could be a method that we're pointing at. It could be a lambda expression. It could be an anonymous delegate. However you want to, pick your favorite mechanism to be able to do that. And so here we're going to do exactly the same code. So in fact, you could even, if you wanted to, actually you can just drag it from the other one. So if you just right click on it and say copy. Yep, copy, and then right click on it and say paste. There you go.
All right.
All right, now in this case, we're sharing the code by, it's essentially, source file sharing, or it's not the most optimal mechanism here. We'll show you a better way. But this totally works. Right? There's nothing necessarily wrong with this approach. Perfect. Just copy all that.
Switching. All right.
So paste it in. All right. So this is now going to be phone text. Yep. Dot text. Perfect. Now instead of set title here on the call button, so get rid of the set title, but keep the call button because that's what you called it. Dot, and it's just going to be text. Equal, and here we just say call, and then text down there with the number. All right. So this is a little more .NET-ish, I guess, from an API perspective, right? Because it's Java, and so it translates a little bit differently. Yep, translate number, perfect. And enable is the same property. Okay, so go ahead and build that for us.
All right, Command B.
Yep. Now, in this case, I have a emulator running here. So if you go down here, the little thing that looks like an 8, right there. Click on that. All right, so there's an emulator. Go ahead and click and drag, and so you'll unlock it. So he's never used an Android device. This man is an Apple man through and through. So we're going to have to train him on how to use all these things. All right, so go ahead and click the run button up there. the run button next to it.
Do I need to switch this?
No, you don't have to.
Okay.
Just click the button. There you go. So what should happen here is we should get a box that will come up. Or it may just deploy automatically if it sees it right away. You may be on so form already.
It's building.
Okay. Is it? I'm
I'm a little suspicious.
Suspicious.
Well, it seems to be behaving the way it was before, actually.
well, it's saved, so yeah, just go
Yeah,
ahead.
why don't I kill it and just
Kill it and start it.
Can you manage the emulators from Xamarin?
Can you do which? Sorry.
Manage the emulators from Xamarin?
Yes, you can actually. Yeah, and so that's what I was hoping would pop up here. Click on it again and hit phone mode. Make sure Android is the selected one and just hit the run button.
yeah, okay.
So hopefully what will pop up here is it'll build, and then we should get the dialog that comes up here. Yeah, there it is.
Ah,
So it'll give you my select device here. I can now click this one and say OK, or I could have started either one of these emulators. So these are the built-in Android emulators. I'm choosing to use one called Genymotion, so it's actually a virtual machine that's hosting Android, so it runs a little bit faster than the built-in SDK ones. So go ahead and click OK. And this will then deploy. All right, so minimum Android, I forgot, this is 4.3. So let's change that. Just double click on that.
okay.
Yep.
Options.
Well, yeah, options, that's fine.
Okay.
And then go to Android application, I think. So here, we want to change the minimum Android version. So I have the latest version, which is KitKat 4.4 installed from an SDK perspective. Let's drop it down to 4.0 as our minimum. So this is just allowing me to say, what devices can I support, right? Android has a variety of versions out there. Only supporting 4.4 is very limiting from an Android perspective because there really just aren't that many devices that do that. So yeah, click on it and click OK. And let's see if it comes up. Woo! And look at that, right? So here we can click translate and we get our same number. So the same thing that we saw on the iOS side, right? The difference is that we had to write UI that was specific to Android and UI that was specific to iOS. But in terms of the code that was actually executing, right, all the code that we went through, and actually most of the logic even that we actually processed here, we potentially could have shared that in some way. Right? So go ahead and switch back.
Wait, before I switch back to the question.
Oh, sorry, go ahead.
Can you put all like your shared code in like a DLL object?
Yes, you can, and that's what we're going to talk about next, all right, is ways of actually doing that. Because this was obviously not optimal from a sharing perspective, right? We shared source files, which you can totally do, and sometimes actually you'll want to do that. There may have been device-specific code that I had in some of those source files that I'm going to compile differently for each one of these platforms. And so when these actually compile, there are compiler directives, __iOS, __Android, and even different versions of the Android compiler directives that are added into the compile process so that you can have conditional compilation in the source file itself. But there's actually a much better way to do this. Switch back to the slides for me, Mike. Question?
The free version.
Yes.
I think they don't allow shared DLLs because it is restricted by PIN or something like that.
Yeah, so the restriction on the free version, as I understand it, is that your code, so the things that you're including that are not part of Xamarin itself, cannot exceed 64K from an IL perspective, the size of the assemblies. Once it goes over that, then it won't compile anymore, so it'll give you an error. So you've got to stick down with the, so what that means is, don't throw Newtonsoft JSON in there. Use system.json, because they won't count that one against you, because that's part of the framework, right? So it just means kind of keeping your app smaller or being smart about which assemblies you pick, but that's the restriction that's there. So it's just your code. It's whatever's in your project itself. Yep, switch. Okay, so let's talk just a little bit about some differences in terms of building cross-platform mobile apps. So first thing is, as you saw, you're going to be designing UI that's very specific to your platform. Right? I actually think that's an advantage, right? Because then the app feels native to that platform because it is, right? It's not going to have different metaphors. For instance, on Windows Phone, the way that we navigate is completely different than the way I would do it on iOS, right? Even in Android, the way we actually do navigation through a physical button typically or some sort of soft button is going to be different. And so give them the native UI, and that's what the platform's going to do. Another thing, when you're actually deciding what your application is going to look like, particularly for Android, this is important, but it's true in iOS as well. Here's my philosophy on this. Pick one platform to start with, right? So don't decide I'm going to do all three of them and try to build them all at the same time. Pick one, get it working correctly in that platform, and then start actually building out to other platforms. You do have the ability to, of course, support tablets as well as phones, and so there's a project that's there on the iOS side called Universal, which essentially builds two different storyboards. One storyboard for a phone form factor, one storyboard for an iPad, but the view controller code is shared. And so it loads one or the other based upon the hardware it's running on. On the Android side, they've got all kinds of interesting ways of kind of managing that. So they use qualifiers and things to say this is the layout file to use, or this is how I want it to size when it's running on a tablet size. But you want to make sure that your UI looks good in all of those different resolutions and in all the different form factors. So keep that in mind. Then it comes down to testing. So if you're going to support a variety of different platforms, you're going to want to make sure to test on all those platforms. And I can't stress this enough. You want to make sure to do actual physical hardware testing. Right? So all these platforms have simulators. We have a nice Apple simulator. We have emulators. On the Android side, they're actually running the Android image. But there are major differences between them, particularly on the iOS side, because the simulator that we use in iOS, the mechanics of it, it's actually running x86. Right? So they've got an x86 image there, and Mono runs differently on the simulator. They do just-in-time code compilation when you're running in the simulator, because they can. It's much faster that way. It also has access to all your memory and all your CPU, so your apps typically run lots faster on the simulator than they would on an actual device. And so you're sitting there in the simulator and things look great, but then you go to deploy it to a real device, and your app's super slow and jerky. Well, you've got to make sure to test. So pick the lowest target that you expect to deploy to and make sure to test. Xamarin actually has a service for this that's really cool. I just saw some of it last week. They call it Test Cloud. It's in beta right now, but the idea is you can actually do CI-type testing, so Cucumber-type testing where I can write scripts in either C# or Ruby, push them up to the cloud, and it runs it on multiple devices. And so then you get an actual result to say, here's what your screens look like on all these devices, and here's how your test ran on all the, and particularly for Android, that's great because, you know, I personally can't afford to go buy 100 different Android devices to test every possible variation of operating system and, you know, form factor in terms of screens and stuff. So that's important as well. So I mentioned the architecture patterns are going to be very similar. You're going to have some shared code here. There are some specific platform pieces that I'll show you in just a second as well. This is going to include things like your business logic, database access, you know, any sort of web work that you do. So if you access web services or cloud services, that would kind of fall into this shared code layer that we can essentially use across all those platforms. And that's really where the advantage is going to be. And then our UI itself is going to be written specific to the platform. And from an architectural perspective, often what I see in terms of people coming that are new to the mobile platform is they think that, you know, there is some specific way that they need to learn new in terms of designing their apps. Well, the reality is that good architecture is good architecture. And so when you're building mobile apps, the types of patterns and things that you do today for loose coupling and separation of, you know, business logic from your views and things like that, those are certainly things you're going to want to apply here. Okay? It's the same exact pattern. So the stuff that you guys already know and probably practice today all works here as well. Right? And so that's exactly what we're going to use here. And so here's a common project structure where I've got a core project that I'm going to actually put all of my business logic into. And then I'm going to have a platform-specific project for each one of my supported platforms, whatever it is that I'm going to actually run with. And I have two different ways of sharing code. All right, I showed you one just a moment ago where we were actually just sharing the source file. And there's a slightly better technique, which is file linking, which you guys have probably seen before as well, where I have essentially a project that has all my source files that I want to share, and then I just link them into each one of the projects that are platform specific. And that way it's the same source file, but I only have one copy of the source file. And that way if I make changes to it, it gets rippled through all of them. It's not a separate copy. But there's actually another way you can do this as well, which is through a portable class library, right, or a PCL, or sometimes you may hear people call it a pickle. How many of you have ever seen PCLs, portable class libraries? Right? So PCLs are fantastic for this type of code sharing. Right? And so I want to show you kind of how PCLs work. So Michael, switch to Windows for this. I'm going to get you out of, you don't have a great track record with Visual Studio. Go ahead and close that. Yeah, close that.
All right.
And go down to Visual Studio there.
That one?
Yep, and just do a file new solution. Yeah, that's fine. File new project. All right, and go to C#. So Visual C#.
Yeah.
Yep. And so notice we have a class library. You do not want that one. So when you pick class library, or actually any one of these platform-specific ones, so Windows Forms, WPF, Console App, ASP.NET, you're essentially tying yourself to a version of the runtime. Right? So in the actual assembly manifest, it says, here's the target for this runtime. Here's what I need in order to actually execute. Portable class library is a new project that they added into Visual Studio 2012. It was where I think it was formally put into the product. They had an add-in for 2010 that you could also download. 2013 is kind of where they really have made it shine. So name this actually, call it hibob.portable. And so he's gonna pick this portable class library, and the portable class library has a unique capability here. So solution name is hibob, that's fine. And so make sure you're on portable class library. I can't see it.
Yep.
Yeah. And click OK.
Okay.
Yeah, great. So we should get a dialog. So notice the dialog that comes up here says, all right, what targets do you want to support? The idea behind a portable class library is that it's truly portable. It's not limited to just one platform. Now, what's going to happen here is, as I select these different platforms, it's going to restrict what my capabilities are. And so it's going to give me essentially the intersection of all the things that I select here in terms of my capabilities within that library. But it guarantees that I can take that one DLL and then run it on each one of those platforms. I don't have to recompile it. It can actually take the DLL and use it in each one of those platforms. Right? And that's something that we normally can't do with a class library. So I can't take a class library that was built for the desktop, for example, and then also use it on a phone project. It doesn't work. Those are two different versions of the runtime. Same thing with Silverlight. I can't take a desktop DLL and then use it in a Silverlight app without recompiling it specifically for Silverlight, right? So that it's restricted to the Silverlight set. And so this is going to allow me to do that. So go ahead and select actually .NET Framework 4.5. And then Windows Store, 8, Windows Phone 8, Xamarin Android, Xamarin MS. So notice the Xamarin shows up here. These are profiles that are supported by Microsoft. And so the profiles themselves are decided by Microsoft in terms of what's supported and what isn't. And Xamarin is one of the core platforms that they actually support here. So when we click OK, it's going to create me a library project here. And so notice it just has a single CS file here. Go ahead and rename that to Bob Service. Yep, that's perfect. Okay? And go ahead and open up the references for me, Michael. So notice the references is weird. It just says .NET Portable Subset. Right? It doesn't list a whole bunch of DLLs. Because what we picked here is a specific profile that says these are my targets that I can actually run against. And so if you double click on this, it'll give you that same kind of dialog allowing you to then change those targets. And so, well, I think you have to right click on the references and say, yeah, or go into the project properties. And then it'll give it to you. But, yeah, that's fine. You don't have to. Yeah, all right, well, that's fine. But you can change it later as well.
You can reference something as long as it meets the same restrictions.
So you can only reference things from this project here that are also portable. Okay, so it's not going to let me actually reference platform-specific stuff, but I'm going to give you a workaround for that. Okay, so that's the complaint that people commonly have with this, because this is actually fairly restricted. For instance, if you add a constructor in there, just put a constructor on there. So just and just type system.io. And so notice the classes that we have here. Right? It's quite.
I don't have system.io.directory.
No, yeah, it's quite a bit different than the normal .NET. All right, because what's happening here is the compiler's being restricted in terms of the types that we have available to us based upon the subset of things that we've said we want to be able to target. All right, so since we picked Windows Store apps, that took out system.io.directory, took out system.io.file. Those classes aren't available for Windows Store apps. We use different classes for that. And so this library doesn't have access to those types. And so yeah, you can see you can change it and turn this off. There's its piece. So yeah, I'm not sure to let you do that, but that's fine. So we have a limit on the types of things we can use here, but let me show you how we can actually get around that. So there's really two different ways we can use these PCLs. One is we can use them to be able to store all of our common code. So for example, that phone word translator class that we used would be perfect to put inside this library, right? Because there's nothing that's intrinsically specific to a version of .NET for that. It's just regular business type logic. So I can totally put it inside here. But we can also actually play a little bit of a game here. The reason that they came up with this, or at least the underpinnings for it, was really because of Windows 8, and specifically the Metro side of Windows 8, all the new WinRT APIs, to be able to run .NET and build apps against the Metro side of this. And so they're playing a bit of a game so that when we run on the desktop side, they're going to load one sort of view of what .NET looks like, but the code is all the same. But when we run the Metro side, it looks different, even though it's really running the same CLR and the same DLLs. And so here's what we can do. Go ahead and add me another portable class library. Call this one.
Yeah,
yeah, you're fine.
Okay,
Call this one BobLib. Just BobLib. That's it. Yep.
Okay.
Let's say okay. And put in there, yeah, same feature
So,
set.
can I do this? What do you want me to do?
No, that's fine. It's exactly, yeah, just exactly the way it works. That's fine. Yep.
Okay.
Just like the other one. That's fine. All right, and make that class just called Bob. So there's a little story here. When I was in university, I worked for the computer lab, and there was an operator that worked at night. His name was Bob, and you know it was kind of a joke to always play sort of pranks because you know we were stupid and young and college students. And Bob was an older guy, and you know he didn't really like pranks. He wasn't really funny and didn't like funny things, and so that made it even more humorous to those of us that you know were a bit younger. And so we ran on mainframes, and he was the night operator that would actually monitor the jobs that were kind of running through. And so we wrote this crafty little piece of JCL. I know I'm dating myself with that word. But what it would do is when it got an abnormal termination, what they called an abend, it would essentially re-inject itself back into the queue, and it was a high priority piece of JCL, so it would always pop at the top, and it would say, "Hi, Bob." And so it would essentially stop that particular, you know, there was only so many queues in the system that would run jobs for. And so it would stop running and it would ask for the password. And that was really funny and, you know, it was great until it accidentally got launched during the day when Bob wasn't there. And people kind of freaked out that they had this job that kept spawning itself. And so, yeah, we got in big trouble for that. But just in kind of memory of that, we're going to create our Bob service. So we've got our Bob.cs. Go ahead and switch to Bob.cs for me. And normally what we would create here is some kind of abstraction. So I would have an interface or perhaps an abstract class that I would derive this from, but I'm not going to do that in this case because we don't really have to do that. But if you want to, you could. We would just have another portable class library that would be the contracts, so the interfaces themselves. I'd want to separate those away from this. But inside here, Bob, go ahead and put me a public method, returns a string, and just call it say hi. So hi, Bob. Yeah, and just return, don't return anything, return Bob. So I don't want this to do anything, okay? The idea is, this is my contract for what I want Bob to do, what I want Bob to look like. We're never going to use this code. This is strictly for the compiler, okay? And so in our Bob service, yeah, you can do that too, not an exception. All right, but in our Bob service, go ahead and give me here a singleton that is a Bob. So you can make it a static Bob service. You can make it lazy if you want.
Do I got a Bob service?
No, you want a Bob.
Okay,
It's
so
Bob.
better do an add reference.
Yep, you're going to do that reference.
Okay.
The magic of ReSharper. There's some people who think the Visual Studio is just a host for ReSharper. All right, so we're going to
It
pick
wasn't
up.
happy, so I'm going.
You were there, yeah, Bob. Yeah, that's right. Yep.
Okay.
There you go. All right, so we just need a Bob, and make it a lazy, just because we don't always want one unless you ask for one. So make it a lazy Bob. Bob, did you call it Bob.lib or Bob.lib?
Bob.lib.
Oh, okay, you put it up.
Oh, I might have to say the whole name. I think that's the problem. I've got a namespace and a class.
Yeah.
You want a lazy of Bob?
Yeah, make it a lazy Bob.
All right, we got a lazy of Bob.
Okay. You know, it's a Bob that sits on your couch, eats all your food, and it doesn't work. Right? Lazy Bob. All right. So make that a new lazy Bob, and just make an onCreate Bob static method there.
Okay.
So pass in just onCreate Bob. Yep. Create that method. There you go. Magic of ReSharper. Just return new Bob. And then create me yeah, you're right there.
Too many Bobs.
Too many Bobs. And then just create me a public static access certificate. That is it.
You want just.
I want a Bob.lib, not Bob. So
You want
public.
Okay.
Yep. Public static.
Static.
Bob.lib.bob.
Why did I name it that?
I don't know what I did that. And just call it Bob. Yep, and just say get is going to be lazybob.value. Okay, you guys familiar with lazyMT? Right? It basically lets me lazily instantiate something. So it isn't until I ask for this value that it will actually execute this method. Right? So I'm not going to create it until somebody says, hey, I want one of those. And then I'm going to hold on to it. Right? And so anytime that you ask for Bob after that, I always get back the same instance. Right? So I've only got one, it's a singleton. but I'm only going to create it when it's necessary. Okay, so there it is. We're going to go ahead and create a Bob and return its value right there. Now, here's the magic. Go ahead and right-click on the solution and add me a, on the solution and add me a .NET 4.5 class library. But call it, go ahead and make it
Bob.lib.
make it bob.lib.net 4.5 or bob.lib.net 4.5, something like that. Something that's unique. All right? Click OK. Now this is a .NET 4.5 class library, so this only works with things that run the full desktop version of .NET. And so what we're going to do here is go ahead and open up the properties for this. And I want this to have the same name and same namespace from an assembly perspective as our bob.lib. So this needs to be...
Because it was such a good choice in the first one.
Yeah. And so this needs to be bob.lib. Okay, so I'm going to make them identical. In other words, they're both building a bob.lib.dll. And I want exactly the same name. And then, you don't need to do anything else, just say that. And it's going to have to be the same version and all that, right? It's got to be exactly matched from a manifest perspective. Now, we're going to create that same Bob class with the same method in it, and this is why abstractions are nice. Normally, I would create a contract here, and then I can just implement the contract and use the interface all through here. In this case, we're going to go ahead and say return hi Bob from .NET 4.5. Yep, semicolon. Do the same thing, but create me an iOS class library with exactly the same class in it.
All right.
And so here's our platform-specific pieces. And here's the magic. What's going to happen is, when we run the app, it's going to load one of these DLLs. Not the portable class library version, it's going to load one of our platform-specific versions. That's the magic of PCLs. They have a special flag on them that says that they're retargetable. Right? In other words, they can actually load a different implementation DLL from what they compiled against. And so when I run on an iOS app, it's going to load my iOS version of Bob. When I run on a .NET desktop version, it's going to load my desktop version of Bob. And that way, I'm going to get something specific. So it's going to be under iOS.
It's running, right?
No, you're not. Go to iOS. Click on iOS.
Oh, I see, sorry.
Yep. And
That
yep,
one?
that one.
Okay, sorry.
So I'm going to load this one. Now this is actually going to be bound to the mono version for iOS. So it's not going to be the real CLR. It's going to be mono's version of the CLR. So name it bob live.ios. Perfect. But change it to have the same name. So properties. And copy that as well.
Hold on. Let me steal this one.
Yeah, that's fine. You probably could just even copy the file, but that's fine.
Yeah, it's probably true.
Yep, just replace it. There you go, but change the text there.
Yes. Okay.
Make sure you're in the right one.
Yeah, this is that one.
Yeah, make that iOS. There you go. Close your string. Close your string. Close your string. There you go. Okay. And then change the properties, but make sure, and this is the key, the assembly name has to match. All right? We want that assembly to be the same DLL. All right? And so this will be bob.lib. And that's what you named the portable, the PCL version, right?
Yeah.
But no, it's got to be it's got to be bob.lib. The namespace has
The
to be
namespace has to match.
exactly right. It has to be exactly the same
I
type.
don't think I fixed it on this one, so.
Yep, it's got to be the same namespace. There you go. Okay, and make sure the PCL version is the same way. So scroll down. Just make sure, yeah.
Oh, it's at the top.
Oh, there it is. And it's bob.lib. Perfect. Okay, so our class looks right here. So we should be able to build this. Should I build it?
Let's try.
Should build it.
It's a true
All right,
statement.
and what we're going to do is we're going to use NuGet. You guys familiar with NuGet? Everybody here seen NuGet? Or I guess the European is NuJ. Is that? I don't know. All right, so go ahead and right click and let's do this. No, I don't want to do that yet, Mike. On the desktop, you have a XML file. So I don't want to type. NuGet's got a horrendous XML file. The easiest way to do NuGet stuff, go find somebody else's XML file and copy it, and then replace all the stuff inside of it. So there's an XML file. Grab that file and copy it into your folder
Which one?
on the desktop.
Copied it, but where do you want to hear?
Yeah, it's
It's like a solution item or something?
Yeah, just so we can edit it. That's all.
Okay, well, when I said I copied it, I meant I was not copying it.
Yeah, that's
Oh.
I don't think you can do that. I think you have to copy it into the folder first, and then you can add it as a solution item. There you go. Yeah, and rename it. Get rid of the XML extension. It's got get rid of the XML. So it just needs to be .new spec. Yes.
Okay.
Now add that to our project. So add existing item. There you go. Sample new spec. That's perfect.
Cool.
Okay, so here is all of our data. So we're going to need an ID first, Mike. So up there, top ID, just make it boblib. So that just uniquely identifies this. Then the version's fine. Title boblib. No, version 00 is fine. Title boblib. We need an author, just make it Bob. Don't care about any of that stuff. And we don't need anything else, so scroll down a little bit. Okay, so here's where we're going to actually identify the file. So we're going to have multiple sections here, one for each one of our target frameworks. And so down here on our files, so file source, so this first one here is our PCL. We have two different DLLs we're going to deploy here. We've got our core portable class library that has our business logic, things that are intrinsically shareable that are not platform specific, right? And potentially I might have a contracts DLL here too, so often you'll have three. And then we're going to have a platform specific version. So go ahead and do a open, just Control O, where are we? So we want to go to iBob.portable. iBob.portable. Right, so we want that. Okay, and then double click on that. And then we want to go to bin, and then release. Okay, so we'll want to build for release.
Yeah, that's good.
Or debug, that's fine too. So hit cancel. Right, so you just want that whole path right here. So make that source. You don't need a dot here in that code.
Right.
Yep.
Okay, so this would be
So that's
lib.
it was Bob.portable, wasn't it? You want the portable one first. Hello, hi Bob.portable. All right, we got to make sure to get the right directory names. So hi Bob.portable /bin/release.
Yeah.
Or bin/debug. Yeah. And then it's going to be /hibob.portable.dll. hibob.portable.dll. Perfect. And notice the target over here. If you scroll down over a little bit, Michael, we've got it's a portable Net45 plus Silverlight plus Windows Phone plus Win8 plus Mono Droid plus Mono Touch. Those are the platforms that this DLL should be deployed for. So as long as it matches those platforms, that's what we're going to use this particular DLL for. Copy that entire line. So copy the whole line, that file source line.
The entire line?
Yep, 33, and paste it back in again, right underneath. And we also want the hibob for that too. And you need to go ahead and put hibob.portable.dll at the end. So go to the very end. Yep. All right, so this is just matching to say what this is going to be. There you go. And so then the other file that we need is bob.live. Yep. So we want bob.live.bin debug. There you go. Yep, and then it would be bob.live.dll. Yep, and then bob.live.dll. All right, everybody follow the pattern here? And then we're also going to want, so go ahead and copy that first line again, so line 33, and paste it underneath the desktop. Replace the one that's there. Okay? We want this portable version for the desktop. So when it's a desktop, we want this PCL here, but our target over here is going to be lib/net45. Okay, so that's specific to the desktop version.
Over here?
No, that's all fine, but change our lib/ this whole target, get rid of the portable net SL, just make it lib/net45. Yep, and then get rid of all the rest of it. Perfect. That's it. And then we also want our platform-specific DLL here. Okay, so this would be bob lib, except that's going to be dot.
That's
net45.
Okay.
Yep. Okay, but everything else is correct. We do need to change all this and make that net45. But I wanted to actually deploy the boblib.dll, right? That's the library that I want to use here. And then we're not going to have an Android version because we didn't create one. But in theory, I would have one for Android as well. So go ahead, and then just copy our two desktop ones for iOS. We want both of them. Okay, and the first one's fine, except it needs to be Mono Touch right there instead of Net45. So Mono Touch.
A little history there.
And then Net45 is going to be Mono Touch. And we want the platform-specific version of that. So instead of
the iOS.
Yeah, and it might be do an open again just to make sure, because sometimes it puts it under iPhone. So go to boblib iOS bin. Yeah, it's iPhone and then
iPhone. Okay.
So put an iPhone in there. Perfect. Okay, so save that and open a command prompt. So down on the taskbar. So in order to build this, we're going to use a tool called NuGet. So just go to your folder. I think you called it. Yeah, I think that's right. And then just run NuGet space pack, P-A-C-K, sample.nuspec. There you go, enter. All right. So successfully create a package. So this is the package that has all the stuff in it. I would upload this to NuGet, but before we do that, we obviously want to test it, so just copy it to the desktop. Just say copy, start up new package to the desktop. Or you can do it that way too, that's fine.
Okay.
And go ahead and open up a new copy of Visual Studio for me. And create me a desktop, just a console.
Okay.
And what's going to happen is when we actually load that NuGet package, it's going to use the desktop version of it, and I'm going to get hello from .NET 4.5. But if I use it in iOS, I'm going to get hello from iOS. But the same code, right? So the platform abstraction is there. So console app. And then right click and say add NuGet as soon as it finally comes up. You're going to go to Solution Explorer.
Okay.
Yeah.
All right.
So right
Add
click,
it.
manage NuGet packages, and go to local. There you go. There's Boblog. Install. Okay, it's installed. Here, just do a console inside your main there. Just do a console right line. And it would be Bob service dot, yep, dot Bob dot say hi.
Ready?
Run it. Hi Bob from .NET 4.5. Okay, so it's loaded the .NET 4.5 version. Right click and just add me an iPhone app. So here is Visual Studio, iOS, iPhone. Just do a hello world application. Yep, that's perfect. That's perfect. Right click and make it the startup. Yeah, double click on that. And say connect, continue. Click marks. Yeah, there you go. Did it? I don't think you did it. Double click. You did something. Double click. So continue. Click on Mark's MacBook. Connect.
Trace close it into the Visual Studio.
Oh, do you have? Oh, I got it. Maybe. Yeah. Close the other one. Yeah. Sorry. It's probably connected. You can only have one connection.
Yeah.
If this doesn't work, then we'll close the build host and try again.
It seems to be taking a while. That's always a good sign.
Yeah, there it goes. Okay. So that connected to that little program that's running on the Mac side. And that's what's going to let us build it. So make that your startup project. Hello.
Yeah.
So say startup, and then right click and add our NuGet package to it.
Yeah, local, that one.
Yep. Say close. Now go to, scroll down a little bit and go to the view controller. So myviewcontroller.cs, and scroll down. So they're doing it all in code because we don't have a designer on this side. So when you build or create the project in Visual Studio, they just create it in code instead. But you could, of course, create the project on the Mac side and then open it over here in Visual Studio and have a storyboard. You just can't end it. So change that title. Just use your same Bob service. Yeah, it's equal to.
Wait, it's
No,
down.
no, it's static.
Yeah.
So just
What did I do?
replace your clicking. Just replace the clicking text.
Okay.
Yeah, just replace the text. There you go. Bob service, Bob, say hi. Run that. Oh, double click, sorry, the project template isn't completely filled out. Yeah, no, close that. Close that. You don't want to do that. Open up your Solution Explorer and just go to your project properties, double click. So they put a nice little piece here, go to iOS application and give it a name. So type in test or hello or something like that. And give it an identifier of com dot, Bob dot something, that's fine. 1, that's fine.
Okay.
Now try it. Now it's actually going to deploy to my phone because the way he's got it set up here, which is fine. It could deploy to the simulator too, but it's gonna stick it on the phone here, just because that's what he did. Let me log into the phone.
I might need to reset the, not that big.
Oh no, it came up. It's up.
It came up?
Yeah, it's up. Comes up. So hold on, let me put up AirPlay here. If AirPlay comes up here, you're wrong. Did we drop off the Wi-Fi? No.
I just dropped off the Wi-Fi.
Oh. Okay, well, hi Bob from iOS. Run it on the simulator instead.
All right.
Switch back. So to run on the simulator, all he needs to do is pull down that marked iPhone here. And actually, yeah, stop debugging. So instead of mixed platforms, Michael, change that mixed platforms to iPhone and simulator. There you go. And then pull that down and say iPhone. Yeah, that's fine.
6?
Yeah, no, make it 7.
7?
It doesn't matter, but iPhone, yeah, that's fine. Run that. And it'll automatically kick us over to the simulator. It should do it automatically. You should even be doing it. But there it goes. So the simulator's coming up. We get our splash screen, and it's still loading stuff. Hi, Bob from analysts. Okay? So it's loaded in a platform-specific DLL. But see, here's the key thing. Because I've got that service there, and it's just simply creating that blob, we could actually use that static singleton even inside the PCL. Right? So we now have a way of actually having platform-specific code inside the PCL itself, because it's going to load a platform-specific DLL to actually manage that code. And if we use abstractions like interfaces and things like that, then it's going to be better. So Michael, one last thing I want you to do for me. Switch back to Visual Studio on the Mac, or on the Windows side, and open up, you just close this one, and just open up on the desktop. There's a project here called Expenses. So I have another project here that's a little more extensive that I just want to show you to give you an idea of what you can do with this. Sorry guys. Yeah, that's fine. And so this is actually a project that targets all three platforms, Windows Phone, iOS, and Android. And it has a shared PCL. And what I'm doing in this library here is, instead of the PCL, instead of having a separate PCL that actually has all my services, that would be great for, say, a class library where I'm a third-party vendor and I'm creating like an MVVM library, I'm creating some services and things like that. That way I can kind of have platform-specific pieces. In this case here, I'm putting those platform abstractions into each one of the platform libraries, and I'm registering it with like a service locator. Right? So we're using a different pattern here. But the same sort of idea would apply here. So notice we have a expenses portable here. If you open that up, Michael, just open up expenses portable. So it's got some contracts, a data layer here. It's using SQLite with SQLite.net. So it's got little attributes that apply. So if we open that up and just open up, actually, open up models for me.
Model.
Yeah, that's the database. So open up expense. There you go. So here's my model that represents an expense that we're actually going to charge. So it's basically just a C# class. If we, yeah, so you can see it's got little attributes telling SQLite what to do with these things. Go back to your Solution Explorer. If you look at the database side of that, so open up expense database. Here's some code here to actually talk to SQLite. This is in the portable class library. Okay, so this is shared code that's going to be used across all three of those platforms. So you can see we're using tasks here. Scroll down. We see this, yeah, so to list, this is actually just SQLite stuff here. And then there's an abstraction on top of this that's going to do any tasks so that it's async. But you get the idea. We can put all that code into the PCL, and then what we have, if you go back to the Solution Explorer, just open up the iOS one. So here, we've got a bunch of views, so open up views, and just open up expenses view controller. There you go. And so here's our table view. We're actually going to display, it has a title, but notice all the code is going through a view model. So all of my shared logic and business sort of things are all going to be done inside that view model. And whenever we have a click or something like that, I'm going to delegate it off the view model itself. And there are even libraries that will do some of this for you. So MVVM Cross is really popular to be able to do bindings and things like that from within Android or iOS. And so this is all my platform-specific stuff. Michael, go to Solution Explorer. And just to show you one specific thing, just go to Platform Specific. There's a folder there in iOS for Platform Specific. Got it? Right there, yeah. Open up Message Dialog. So notice this implements an interface called iMessage Dialog, which is used from within the PCL to display an alert message. So inside the portable class library, it's going to request some implementation of this interface. And so each one of my platform-specific projects then implements that in some way. So it's going to have this one for iOS, where it's going to use a UI alert view. If you look at the Android version, Michael, so Solution Explorer, Android, platform-specific. So, yeah, platform-specific. We've got one right there, same thing, but this one is actually using Alert Dialog Builder. So that's the Android variety of this. But the idea is the PCL itself doesn't care about that. It's just going to go to Message Dialog here, this interface, and say, show, here's the message and here's the title. And then the platform-specific version will actually display something. Okay? So that's kind of the idea with this here. If you just run that, go ahead and pull down some mixed platforms here and pick me iPhone Simulator. Alright, so we'll just run it on the, oh, we may not be connected. Hit refresh. Yeah. Refresh and build server. Are we not connected? Go ahead and build it. You may not want to build it. So make it, go ahead and pull this down. Let's use the other one, mixed platforms. Yeah, so go ahead and run it on Open up Solution Explorer and make the.
Oh, it's because
Yeah, hold on. That's okay. Actually, run that. Run it. Because this is interesting. This analysis project, what it does is it goes across all those source files and tells me how much is shared. And so notice here, we have a total of 1,248 lines of code for Android, of which 303 are unique and 945 are shared. Okay, so it's looking across the PCL and the platform-specific project, and then telling me how much sharing I'm getting across them. All right? So yeah, go ahead and make the iOS project the startup one. Set a startup thing. Yeah, that's right.
And let's try this again.
Yeah, there you go. So run it now. And so this will pull it up in the simulator. Oops. Deployment errors. What does it say there? Okay, we'll scroll up. Scroll up through this. Do reload. Let's see what it says now.
Who's better? Slow.
Okay.
It's always good. It's good.
Okay. And it should pop over to the simulator. And we could run the same thing in Android too, but it's easier to run in iOS here. There it goes. And I'm going to get an iOS specific UI here. And it's doing two things. First, it's actually going to hit a web service. It's going to pull down some stuff from a web service.
That might get tricky.
Go ahead and, yeah, you can just close that.
Yeah,
I think it's right, oh, we don't have a network connection.
Yeah.
Well, it's probably not going to pull down from a web service.
That's what I'm thinking. The chances are low.
I'm not sure there's actually error code in there for that.
It might have already not done it.
Let's switch over to Visual Studio. I'm guessing it's either still loading assemblies. Look at the output. No, it's starting. Yeah, it probably is waiting. I'm guessing it's waiting to time out. Yeah, without a network, that's not going to work that well. So yeah, sorry, it needs a network. But it's going to pull down from a web service and actually pull a set of tasks. And then the Android version does exactly the same thing. And Michael, just to show them that, go to Solution Explorer, go to the portable. And it is in services. And so expense services, if you scroll down a little bit, you can see here we're just basically doing task runs. And so again, this is the portable library. This is one's going to be shared. And if you scroll down a little bit further, we should have, here's all our deserialization that's going to happen. Go to the Solution Explorer. I'll load the taskbar. And what I want is the expenses view model. So these are just view models. They're using iNotify property changed. So this works in Windows Phone. I haven't ported it to Surface, but in theory it could. And so we look here. Here's our get expenses against our service. And so notice async awaits, right? Allows me to do asynchronous kind of stuff without me having to marshal back and forth between threads. So all that works as well. And then here's our load. So go to this execute load alert. Yeah, so this load right here.
Oh yeah, I think
Got that? And if you look here, this is basically going to go use HTTP client. And then we're going to go get our value here. And notice right here, we're going to do a message dialog.show. That message dialog is that iMessage service. And so on Android, it'll use an Android-specific version. On iOS, it uses an iOS-specific version. Okay? But the code to actually do the processing of it is all going to be shared. But where we have to drop down to an actual platform abstraction, we just use interfaces to do that. Okay? But it's going to let us then share the majority of our code where we can. And stuff like this, HTTP client, is completely shareable already. So I don't need to do anything for that. Okay? So I can use that on Windows phone side. So that's pretty cool stuff. It's going to let me then target all three of these platforms. So I'm assuming we still don't have network connection. So it show there. That's fine. So what do you guys think? Cool stuff, right? Right? So you can use the skills that you already know, that you've spent years refining, right, of knowledge of C# and the frameworks that you use to now be able to target mobile apps as well. Okay? And so all you have to do is go to xamarin.com/download, and you can go download a free version of this. You can only create small apps with it, but actually some of the smallest apps out there are the ones that have made the most money. So, and then you can deploy it to the App Store, or to the Google Play Store, or to Windows Marketplace. So cool stuff. All right, guys, any questions? Yeah, go ahead.
Do you have any handouts links with specific version of Facebook
Of what's available in
like a kind of walkthrough of what you've walked through?
Yeah, so what I'll do is, Michael, go to the first slide. Go to Tom. Slide there. Yeah, so down one.
Oh.
That's fine. No, you're good. I got you. One more. There you go. I'll put it here. So if you go to julmar.com, julmar.com, you can find it. And actually, you guys have this slide, so you should have it in the materials. Just watch there, and I'll post the samples that are here as well. And so yeah, I'll do a recap of what we talked about. Great question. Other thoughts?
I have a question.
Yeah, go ahead.
With reference to the iMessage dialog stuff you showed, I mean, that's very optimistic. I mean, in the sense that it works like, probably just an example.
Yeah, absolutely.
Absolutely. I think that works, so correct me if I'm wrong.
Yep.
So that works because you only expect to display an OK button.
Correct.
Yeah,
For that,
because,
yes.
Yeah,
that's right.
Because in Android it's really impossible to get a dialog result back
Right.
In a synchronous way.
Yes, that's right. And so what I would do is if I had to actually get the response back, I would change the way that interface is written. So where I would make a task of some response.
And can you do that?
Absolutely.
I mean,
Yeah.
Can you find out a reasonable way of making the thing works across all platforms?
Yes, absolutely. Yeah, I've done that. So, because you got the same thing in iOS. That's an async dialog, essentially. You're registering a delegate to say,
In iOS,
in iOS it works the same way, yeah. So they've got an event that fires when you dismiss the dialog, and it tells you, here's the button that was clicked.
I'm familiar with Android much more.
Yeah, right. Yeah. So yes, absolutely, you could build one that was cross-platform. That but what you would have to do is make sure it returns a task of something, whatever your abstraction is for the result itself, and then you could do an await against it, and then whenever it came back with your data, you'd have it. But yeah, absolutely, you can do that. Other questions? Yeah. Go ahead. Yeah.
Is there any templates that we can use? For example, we have Bootstrap web applications. Do we have any templates which we can use to start with the UI?
To start with the UI for all three platforms?
Yeah.
Yeah, so today, because the UI itself is going to be platform specific, you would actually just create each platform project independently. And then it would generate, whatever UI is kind of consistent for that particular platform. Storyboards in iOS, a layout file.
Or does it not have any
Android.
specific templates as part of?
No, so Xamarin doesn't include any cross-platform templates, but I can tell you definitively that will be there at some point. That is definitely on the roadmap. Like in the next, they've got to get this next release, this designer done and out the door in the next month or two. And then once that happens, that'll be one of the primary focuses. So that's one of the things that we're looking at now. So yeah, that's kind of.
I know this might not be a problem with iOS, but in Android we have different various fragmentations, especially 2.33, still a massive install base.
Yep.
So what is the memory profile between Eclipse-based application and the Xamarin application?
Yeah.
in Android?
Great question. Yeah, so the answer is it depends. It depends on what you do and when you do things. Because as I said, when you are looking at, particularly in the Android side, where you have two different virtual machines that are kind of competing for things, let me give you a perfect example. So in the Android side, whenever I have what's called a list view is like a list box or a table view in iOS, okay? It presents a series of items that I can then tap to activate or select or do something like. In the Android documentation, you'll hear them say, oh, you can use essentially a string adapter or a base adapter of T that then lets you, it's an array adapter is the class I'm thinking of. So there's an array adapter in Java that you can use to where you can say, hey, it's an array adapter of strings or whatever that I'm going to use. The problem is, Xamarin's wrapping array adapter, which is really a Java class, okay? And on the Java side, when they store those values, they're storing them as java.objects. Well, when we're creating stuff on the C# side, we're creating C# objects. They're not Java objects, they're C# objects. And so what happens is the minute we try to put them into a Java-based array, the system's got to go over to DevWeek, the VM on the Android side, and it's got to create a little wrapper. It's kind of like boxing, for types in .NET, where I've got an integer, I want to put it onto the managed heap. I've got to box it in a system.object, and there's a performance penalty with that, along with a memory penalty. And so if you use, for instance, array adapter, and you've got 2,000 items, you're going to find your performance is going to really suffer as a result because of what's happening. Well, the way you work around that is you don't use array adapter. And so, in that particular case, you would create your own adapter that's specific to your type, and you would keep it all on the .NET side. And so that's really the key, is you just have to be thinking about that and recognize anytime that you're kind of trying to capture an object and hold it in both worlds, that's where you're going to run into trouble with memory and performance. And so trying to, and that kind of advice is true even in the .NET world, right? They'll tell you if you've got native DLLs that you're interacting with, don't go back and forth between the native and managed world constantly. Try to stay on one side or the other and do big chunks of work and then pass data back and forth. So the same rules kind of apply here because we've got that VM. It's not so much on iOS because iOS doesn't really have a VM there, right? So they're just kind of managing reference counting. They have their own issues with that, right? From a memory management perspective, you have to be a little bit, ultimately the idea is, for instance, if I have a image view that I've captured and I'm holding a reference to it, that can actually lock that image longer than what would really happen in iOS. And so you just want to be careful of things like that. Again, like .NET, you would just do dispose to kind of get rid of some of that stuff and make sure that it goes away. So yeah, I mean, that's where you run into trouble. Great question.
Mark, I'm running to my talk.
Bet you, man. Thanks, Michael.
Yeah, thanks, guys.
Other questions? Yeah.
Just thinking, like, you've got lots of libraries and everything that you've written sort of for Windows-based applications. I mean, we haven't done any portable libraries or anything like that. What's the sort of best way to sort of move over to the portable world there?
Yeah, so what I would say is again, portable libraries have some restrictions in terms of what classes they have access to, right? And so my personal preference is to pick the loosest restriction I can, because that's going to give me the widest things of availability. And in particular, I would not select Silverlight or Windows Phone. Those two in particular tend to be very, well, Silverlight's not quite as bad, but Windows Phone is very limited because the platform surface that's available is just limited. And so what I would do is start taking some of your class libraries and creating a portable class library and just move your classes into it and see what compiles and what doesn't. And then you'll get a sense of what you're going to be able to put there and what you're going to have to abstract out to something that's specific to that, a broad range of things. But that's generally what you're going to do. But yeah, DCLs are great for that because, again, it gives me a binary DLL that then I can ship. Thanks, guys.